All right. Welcome, Unit 1, Measurement and Math, pages 5 through 6. Our measurements done significantly, and that is more fun than you can shake a stick at. Let's go. You may learn sig figs and chem. In fact, you better remember some of it. Fortunately, we use it. It's important, but there's no heavy testing on it in this course. So follow along with a bit of a relaxed stance. All right, let's go through here. So when we make measurements, we use different tools. We use rulers with different degrees of tick marks on there. We use protractors. There's all sorts of things that have different ways that they measure their accuracy. Basically, how many tick marks do they have? How much spacing is between them? So, basic rule from chem. You read the numbers off the tool and you get to include an additional guess digit. So what do we mean by a guess digit? Well, let's come down over here and we can look just at the top half of the ruler. Let's look up here. There's this orange arrow. And if you notice, there are a bunch of digits on it. Here's the 0 mark. Then there's 1, 2, 3, 4. What's the length of the arrow? Well, it's pretty clear that the arrow is at least to 4. Here's the 4 line. Arrow, in fact, seems to go beyond 4. Okay. Well, what can we say? Actually, if you come down to question number 10, which is based on the upper ruler, that's the one we're looking at. How long is the arrow? Well, you'll say 4. Let's say most reasonable observers will say 4. But then there's a point. What comes after the point? Well, that's the part where we have to start thinking a bit more. 4 point what? Well, is it all the way to the 0.1? This is the 4.1 line. So is it all the way to the 4.1? If you say yes, if you say I can see the tip of that arrow reaches the 4.1, then you write 4.1 down here. If you say no, that arrow falls a little bit short of 4.1, then you come down here, you still say 4, but then you have to put 4.0. You have no choice. However, neither of those are guesses. Either you think it hits the 1 or you think it does not. If it hits, you write 4.1. If it does not, you say 4.0. That's not a guess digit. Now you get to add what we call our guess digit. So does it hit the 1 exactly? If so, your guess digit will be 0 and your answer will be 4.10. If it goes slightly beyond, you will say 4.11 or perhaps 4.12. Most of you will probably limit your guesses to that number maximally. Maybe you could say 4.13. But some of you will say, no. This does not hit the 4.1. It's a bit less. So your guess digit, well, how much less? It's certainly not 4.00. It's certainly close to the 0.1. So maybe you'll say 4.08 or 4.09. Put commas between these different options. You might even go so far as say, hey, you know what? It's a bit shorter than that, 4.07 or even 4.06. So what's the point of all these? Well, actually, all of these are legitimate answers. All of these are correct in a scientific regard. You may say, how is that possible? Well, you can read whether it's 4.0, 4.1, and you get something called a degree of accuracy. Now, no measurement can be made perfectly, and so this degree of accuracy gives you some wiggle room. How do we define that wiggle room? Here it is. You basically take the distance between the tick marks. In this case, beware. This is actually a close-up of our protractor ruler that we use, and it does say mm. You say mm, oh, this is a millimeter ruler. Well, actually, this ruler, the little tick marks are a millimeter apart, but these big numbers are actually centimeters. 1 centimeter, 2 centimeters, 3 centimeters. Beware of that. You often get rulers like that, and they only confuse you on test day when you're really worried about being right. So your pinky is about 1 centimeter thick. So if you put your pinky on it and it fills the space, then it's probably 1 centimeter. Okay, so here, the degree of accuracy, if the spacing, if the little lines are 1 millimeter apart, so 1 millimeter spacing, cut that in half, that is 0.5 millimeter degree of accuracy. Now, you can turn that into centimeters. That would be 0.05 centimeters. We'll worry about those prefix conversions a little later on. You can even put that in meters, 0.0005 meters. But this degree of accuracy gives you a plus or minus. So if we were to claim Let's say the manufacturer of that arrow claims it is a 4.10 arrow. Well, any measurement made within 0.05 centimeters, either more or less, actually counts as a legitimate measurement. So here, the scale is in the tenths place. That's those tenths of centimeters. So you can guess to the nearest, one more guess digit, you can guess to the nearest hundredth. And basically, the right way to write this answer would then perhaps be 4.10 plus or minus 0.05 centimeters. Now, you are only going to pick a singular answer here, whether it's 4.06 or 4.09 or 4.11. You have to judge this by your eye, and you are assumed to be a reasonable observer. So be reasonable, meaning you actually have to pay attention to the measurement you're making. Okay, any of these actually count as correct. Now, if we take the same arrow and instead look at the lower ruler, let's just look down here. Question 11 concerns itself with the same arrow aligned with the lower ruler. The lower ruler only has centimeter tick marks. 1, 2, 3, 4. So in this case, your 1 centimeter spacing, the degree of accuracy becomes plus or minus 0.5 centimeters. That's all you get here. 0.5 centimeters, which is 5 millimeters, which is 0.005 meters. In this case, you don't get the same luxury you had with the upper ruler. Now, the scale here is in the ones place, so you only get a guess digit to the nearest 10. How are you going to go about this? Well, let's try it out. Some of you will say, clearly, that's up to the 4 mark. The 4 mark is right about here. Clearly, that's up to the 4. In fact, look at the one on your paper rather than the one on the video. The one on the paper you can see closer and better. All right, so it's up to the 4. Fine. If it's all the way up to the 4 with certainty, you would write 4. If you don't think it quite reaches the 4, it's slightly short of the 4, you have no choice. What's less than 4? You have to write 3. But now you get a guess digit, and that guess digit is in the tenths place. So point, fill in your guess digit. Point, fill in your guess digit. You don't get much in the way of room here. In this case, 4 point, what do you think it is? You could say 4.0 if you think it's dead on. If you think it's enough past 4.0 to warrant a 4.1, then go ahead. To me, it doesn't look like you can claim a 4.2. But, in fact, 4.2 is not wrong, because technically, you do get plus or minus half centimeter. So, does that fall within half centimeter of perhaps around 4 or 4.1? Sure it does. If you think it's a little less, the next lower number you can pick is 3.9. You can't put 3.95. This ruler does not justify it. In fact, if you wrote that, it would literally be wrong. You may say, well, why would I use a ruler like this one when I can just use this one? Well, because you don't always get the choice. Here we're measuring arrows that are centimeters long. What about when you're measuring atoms? Now, we're not going to measure atoms in class here, but there are people who are being paid to measure very tiny objects. And when you have very tiny objects, you can't make rulers with tinier tick marks. You're going to use rulers that, relative to the size of the object, have big tick marks. And so now you can't make claims like 3.95. You only get 3.9. Heck, you'd still be legitimate claiming 3.8, but probably beyond that, even though the degree of accuracy is half centimeter, probably beyond that we would call unreasonable. So part of sig figs in measurement, you have to be reasonable. There is no singular set of rules that allows you to get around all issues. Okay, so that's for how to read off a measurement device. That's actually perhaps the most useful part of what we're doing in this video, even though it's not really a big part of our testing. Okay, let's take a break over here. And let's get on to the next comment, which is counting sig figs. Once you have a number rather, how many sig figs are there? Well, you probably learned 3 or 4 sig fig rules. I don't know why you learned 3 or 4, maybe 5. You really only need 1, and here it is. Lead zeros are not significant. There's the rule you need. Now, of course, what's a lead zero? If you run up on the side there to our vocab bar, you will see a lead zero is a 0 at the beginning of a number. So, lead zeros are not significant. Okay, what does that mean? Well, look at your numbers. We can start on this one. Let's start here. Question 12 says, how many sig figs are in each answer? So if you go to question 10, that's our answer up here. How many sig figs? Well, you might have picked 4.06. Do you see any lead zeros? No, so there are 3. 4.10. Any lead zeros? No, there are 3. The 0 at the end, this one, that is significant. That counts. 4.13. You see any lead zeros? No. Those are all 3 sig figs. How about question 11? You got 2. You got 2. No matter which answer choice you chose, you get 2 sig figs. By the way, a little note over here, though you won't see it writing on the board with the digital ink, when you write on your own paper, don't just write .55. You might overwrite that decimal, or it might be very light, and I'll look at it and say, oh, 55. Ooh, you're way off. If you put a 0 in front of it, even if your decimal gets overwritten a little bit, I'll look for it. I'll say, wait a minute, why would they put a 0 there? There must be a decimal in there. Let me look close. Okay, now, there's an exception here about trail zeros. We'll mention that on the next page. Let's go to the next page. Let's count the sig figs in each of these. Remember the rule. Lead zeros equals not significant. Okay, so let's do it. Perfect. Lead 0, lead 0, lead 0, not 1 sig fig. Lead 0, lead 0, lead 0, not 2 sig figs. Not 5 sig figs. All of these actually represent something about the measurement. With this number here, what they are saying is, not only could I read to the ones place, I could read to the tenths, the hundredths, the thousandths. I could see the tick mark for the thousandths, and then my guess digit is for the 10,000ths. Those are all representing actual measurement. That's why those extra digits matter. That's why the 0 at the end matters. Now this here is our funny case. Your chem teachers will yell at me for saying this, but depending on the context, you could say this is 2 or 3 sig figs. If you have a trail 0, this is the one exception, with nothing written, this could be 2 or 3. Typically, you just put a decimal at the end there, and that clears it up. That would make it 3. But how would you write it for 2? Well, so the footnote comes in. Footnote 1, jump down to the bottom here. Generally, we will write it then in scientific notation. So if you want it as 2 sig figs, you write 1.2 times 10 to the 2. You want it in 3, 1.20, times 10 to the 2. That situation won't come up much, though, so I won't worry too much about that. Finally, no lead zeros. Even those middle zeros count. 5 sig figs. There you go. That's how you count them. All right, the last step is, how do you do math with them? Now, we will always do our sig figs correctly. When it's a test question, when it's a multiple choice, you look at the answer choices. So you got to be careful with this. You might have an issue knowing whether your calculator matches the multiple choice answer choice. In truth, most of the time you won't. But here it is. Beware the sig fibbing calculator. What do we mean the sig fibbing calculator? Basically, you enter something like this. 13.1 divided by 28. You get all this business over here on the side. You write it down and you're good to go. You feel good. You must have given a more accurate or a more true answer, correct? This must be more true if we write all these things, right? Wrong. It's not more true. It's actually a lie. So, how do we do this? Here's the rules for multiplying, dividing, adding, subtracting. Again, don't get test anxiety over this. This is something you should know and that we use, but you don't get particularly tested on. Let's start with multiplication or division. What you do is you count the sig figs in each number. 537.4 has 4 sig figs. 12 has 2 sig figs. When you multiply or divide, you just take the minimum number. So this has 4, this has 2. The minimum, of course, is 2. So your answer, the calculator will say 6,448.8. That's fine and all, but we need an answer with 2 sig figs, not 1, 2, 3, 4, 5. This literally is wrong. If these numbers represent measurements, this is lying. You have to make it 2 sig figs. So the 6 is still in the thousands, the 4 is still in the hundreds, and it's not rounded up. And then these over here are just calculated. That's just sig fibbing by your calculator. And measurement true answer is 6,400, and that's it. What about addition and subtraction? Okay, you have to do addition and subtraction. Here it is. Count them up again. 141.2554. That's 7 sig figs. 7.59. That's 3 sig figs. If you were multiplying or dividing, your answer would have to have 3. But you're not. You're adding or subtracting. In that case, you look at the sig figs after the decimal. Here's the decimal. It's got 1, 2, 3, 4 after the decimal. This has 2 after the decimal. Take the minimum to the right of the decimal, and your answer needs to have that number to the right of the decimal. So this has 2. The minimum is 2 to the right of decimal. So your answer better have 2. Right here it has 7 sig figs, but more importantly, it has 4 to the right of the decimal. So that is incorrect. You're only allowed to have 2. So the 148 is fine. Then point. The 8 is still 8. The 4 actually gets rounded up by the 5. So the 5 rounds us up to a 5. And then after that, you're not allowed anymore. You don't put 2 zeros there. You put nothing there. There's your 2 sig figs after. Here is your measurement correct solution. There it is. So if you want a quick bonus, put on a little post-it, write this answer to the correct number of sig figs. Enjoy.